say?
Name some examples of scale factors that are less than 1. What effect does a scale factor less than 1 have on the dimensions of the image being scaled?
Okay, so yesterday in class, we talked about what happens if we have a scale factor less than 1. So if we have a scale factor that's less than 1, what would happen?
You get smaller.
Yeah, we're going to get smaller. It's going to reduce. So give me an example of a number, either a decimal or a fraction that's smaller than 1.
2/4.
Yeah, 2/4. And 2/4 is actually in decimal form is equal to 0.5 or 5/10. Okay? Does anybody else have an example of one that's less than 1?
1/2.
1/2, good. And is that would actually be what? This and this are what to each other? Equivalent. Yeah, they're equivalent. That's okay. So equivalent means equal to or the same as, okay? All right. What about, tell me if this would be, what about 1/4? Is that smaller? Yeah. So if we take a calculator and we did 1 divided by 4, what would we get? Everybody try that in your calculator real quick and see what you get. Anybody got it? If 4 quarters makes $1 and you have 1/4, what would it be?
0.25.
Good job, Isamian. All right, so these are 3 examples of a fraction or a decimal that is less than 1. And we said that if we have a scale factor that's less than 1, the original image will do what? Get smaller. And so our word that we're supposed to know is reduce. All right, let's read that second one. Read part B on number 5. Najela, will you read it for us?
Name some examples of scale factors that are equal to 1. What effect does a scale factor equal to 1 have on the dimensions of the image being scaled?
All right, so what happens? If the scale factor is 1, so it's exactly the same as the original, what's going to happen?
It gets bigger.
All right, so I got one person that says it might get bigger if it's 1.
It's still the same.
All right, Jamal says it stays the same. So let's take an example. Jamal, give me a ratio.
3/6.
All right, so I got 3:6. Okay, and my scale factor is 1. So that means I'm going to multiply both of these by 1.
You get the same number.
Yeah, because 3 times 1 is,
3.
and 6 times 1 is. All right, so check this out. If I have 3/6 and say my scale factor is 2/2, what does 2/2 simplify to?
1/2.
Yeah, it equals 1/2. So since that equals 1/2, the same thing's going to happen here. What's 3 times 1? And what is 6 times 1? All right, so in this case, if the scale factor is 1, what happens to the original figure? It stays the same. So that's B. And so some examples would be like 1, 2 over 2. What's another one? Somebody give me another one. 3 over 3. Good job. 4 over 4. Great job, man. That's some perfect examples. So that's B. All right, let's try C. Jamal, read C for us.
Name some examples of scale factors that are greater than 1. What effect does a scale factor greater than 1 have on the dimensions of any scale?
All right, let's see. Emma, what do you think is going to happen if we have a scale factor that's greater than 1? Say our scale factor is 2 and our original figure is 1 to 2. What is going to happen?
It's going to get bigger.
All right, how many times would it get bigger?
2 times.
2 times, good. Because 1 times 2 is 2, and 2 times 2 is
2 times 2 is 4.
good. All right, so that means anytime we have a scale factor that is greater than 1, the original figure is going to enlarge. And what does enlarge mean? To get bigger. Good job. Does anybody have a question?
No.
All right, good deal. All right, let's go to the next question. What's number 6 say?
For one of the copies
I can't hear you no more, Jamal. Now I can hear you.
Where you want me to read it? Like where it says 6 at?
Yeah, number 6, the question.
Okay. Reinforce. Nathan has a photo that is 5 inches tall and 8 inches wide. He plans to print copies of a photo in different sizes.
All right, so we got 5 inches by 8 inches. And the first time, what's he want to do?
Copy the photos in different sizes.
All right, so on A, what does it say he's going to do?
For one of the copies, Nathan enlarges the dimensions of the original photo by a factor of 3. What are the dimensions?
All right, so if the factor is 3, what does that mean we need to do?
Multiply.
That's right, we're going to multiply both of the original sizes by 3. So what's 5 times 3?
15.
Good. What's 8 times 3?
20.
Good. So does everybody see what the new dimension would be? Anybody got a question about how that works? All right, let's go to B. Jacaden, read B for us.
For another copy, Dean, that's how you say his name, the Dean.
Talk a little louder, Jacaden.
For another copy, how you say his name, Nadine,
Sounds good.
shrinks the estimator of the original photo by a factor of 0.75. What are the estimators?
All right, the new dimensions.
The new dimensions.
All right, so what do we need to do with our scale factor?
It goes down.
What have we been doing? Multiplying. So somebody get those for us real quick. What's our new dimensions going to be? You might have to put it in your calculator. All right, so what you need to do in your calculator, you're going to put 5 times 0.75. You probably didn't put the decimal in.
It's 3.7.
My light went off. I had to turn it on. Sorry about that. All right. So what did we get?
3.75.
Perfect. All right, what did we get for 8?
6.
All right. Does anyone have a question about how we got these? Good deal. Let's go to C. This is my favorite part of this question. Makes you think. Read C for us, please, Miss Halen.
Nadim has a 10-inch by 10-inch photo album. He wants to make as large a copy of the original photo as possible to fit in the album. What are the largest dimensions the copy can be if he keeps the proportion of the original photo? Explain your answer.
All right, so the biggest we have is a 10 by 10. That's how big his book is, right? His original image is 5 by 8. So what is the largest that my picture can get to and still fit on the page?
10 by 10.
Yeah, 10 inches, right? So out of these two, is 5 or 8 the greater number? Is 5 or 8 the bigger number? 8 is the bigger number. So that means we got to see what we can multiply 8 by and it become 10. So who knows what we could do to figure out what that number would be? Great job. So we can do 10 divided by 8, and that's going to tell us our scale factor. Good job. So our scale factor is 1.25. So that means we need to take 5 and 8 and multiply by what?
1.25.
Good deal. Let's do it. All right, so what's 1.25 times 8? We should know that because we just did 10 divided by 8 is 1.25. So that means that 1.25 times 8 is 10. All right. Does anybody, Roy Kia, do you have the answer to 1.25 times 5?
50.
Close. All right. 5 times 1 is 5. And so how much is 5 times 25 cents? If we had 5 quarters, what would we have in dollars? That's right. We'd have $1.25. So what's $5 plus $1.25?
$6.25.
There we go. So our new measurements would be what?
6.25.
And 10. Does everybody see why that's the largest that you could put in there? Could I go any bigger than a scale factor of 1.25? No. If I did it any more, then that would mean that the picture was too big for the what? Yeah, for the photo album, the dimensions of the photo album. All right, so that concludes the homework for yesterday's lesson. So what we're going to do is we're going to pick up on our lesson today, which is still working with enlarging and reducing images. All right. So our actual goal and objective for today is that we're going to enlarge and reduce objects using ratio tables and equations. We're going to determine scale factors of 1 and 2 dimensional measurements. So I'm going to erase this off of here, and we are going to get ready to go to our next slide in exploring our scaling images. And so we're going to be on page 7 of the computer, and in our book, we should be on page 9. So make sure you have your math book open. All right. Faith, will you read this for us, please?
Oh, you mean that's highlighted?
I want you to read all of it.
Okay. In the real world, you do not have
A slider.
a slider to help you scale images. Sometimes you do not know the scale factor, but you know the
Dimensions.
dimensions you need. Here in a example, Mark wants to enlarge the school logo for a
Mural.
mural on the building. He knows the dimensions of the
Original image.
image are 8 inches by 10 inches, and he knows a mural
Mural.
mural must be 68 inches wide to be on the on the wall. How can you find the scale factor to dimension
Determine.
determine the right height of the mural?
Good. All right. So when we look at this, we're trying to figure out how we can find the scale factor to determine the right height for the mural. It says he knows the dimensions of the original images are 8 inches by 10 inches, and he knows the mural must be 68 inches wide to fit on the wall. So, what do we need to do to make it fit on that wall? What is the width of the original image? Say that again. All right, it is 8 to 10, but I want to know what is the actual width. So looking at that picture, what is the width? It's 8 inches. All right. So what do we need to do to determine how to make it 68 inches? Or what scale factor, how could we figure out the scale factor to make it become 68 inches? What did we do earlier when Jamal told us how to work number 6?
Divide.
That's right, we divided. So what do I need to divide?
8.
That's right. All right, so we're going to do 68 divided by 8. So I want everybody to put that in your calculator, or you can do it by hand. Either way is fine with me. We know that 8 goes into 68 how many times? 8 times 8 is 60, what? 64. So if we subtract, we're left with what? 4. So we are left with 8 and 4/8, which simplifies to 8 and a half. Good job. All right. And so we can write 8.5 like this, or we could write it in decimal form. What is the decimal form of 8.5? Good. So what's our scale factor going to be?
8.5.
Good deal. So what do we need to do with the scale factor?
I think we need to multiply.
That's right. So right now we know that 8 is going to become 68, right? But what we don't know is what 10 is going to become. So what do I need to do to 10?
We need to multiply by 8.
Good deal. So let's do that. 10 times 8.5. What's that going to be?
85.
Good deal. So our new measurement is what?
85.
By, say it again, Jamal. Say it loud.
85 by 68.
Good job. All right. So our new dimensions are 85 by 68. All right. Let's see if they go and work it through for us. They probably do it all for us, but we just did it ourselves because we're better. All right. So let's see what it shows. And I'll erase this off of here. All right, so once again, they're looking at this and they know that they need to use 68 and 8. All right, they know they're both the width, right? So they took the quotient of the widths, which is what we found because we did 68 divided by 8. So know that the quotient means the answer to a division problem. All right, so if you're looking at your workbook on page 9, you should be right here answering these questions. All right, part A says, what is the quotient of the width of the mural to the width of the original image? The quotient was what? What did we find? 8.5. All right, and what is the scale factor? Isn't the quotient and the scale factor the same? Mm-hmm. Y'all are making Jamal work hard. I don't have many other people working with us. So it said use the scale factor to calculate the height of the mural, and we did that. What did we do? Yeah, we multiplied. We did 8.5 times what? 10. And so when we did 8.5 times 10, what do we get for our new height?
85.
All right, so A, we should have what? What should we have for B? And what should we have for C? Look at it close. It says the height. Well, we did it. We did 10 inches times 8.5. And what did we get for our answer?
We got 85.
Yeah, we got 85. All right. So go ahead and look at that next one. It's showing a new measurement, right? On this new measurement, it says that Mark wants to increase the width of his image from 5 inches to 30 inches. All right. So we got to figure out what scale factor he should use. All right. So what I want you to do right now is I want you to work on your own to answer the questions on this page. Okay. I'm going to give you, I guess, about 4 minutes to try to do this on your own. Okay. You're lagging bad, buddy. All right, so let's look at this. It says, what proportions can we use to create using the scale factor? Well, the first thing we had to do is find the scale factor, right? So right here, we notice that he wants the new width to become 30 inches. All right, so what did we do in the last problem that we can use here?
Multiply.
Okay, so we actually divided earlier, but tell me what you would multiply to get 30.
From 5.
Yeah, from 5 to 30, what would we do? Yeah, we'd multiply by 6. So 30 divided by 5 is 6.
6.
So that's our scale factor. All right, so what do I need to do with 7 and 6?
You need to multiply.
Good job. And so what's 7 times 6?
42.
Good deal. So our new length is what?
30 over 42 or 42.
So 42 inches. Good. All right, so let's check our work. Make sure we did that all right. All right, that's looking good so far, right? Let me erase this off of here. And we'll keep scrolling. So it said, what proportions can you create using the scale factor? And so we actually did this. So, except we did it kind of backwards. So it says 7/5 is equal to 42/30, or 5/7 is equal to 30/42. All right, so notice that here they have what on top? The length or the width? The length, good. And on this one, they have the width. Does it matter? No. Either way, we still got the right answer, right? Good. All right. So it says you can use the scale factor of the equation to find the new length. So what equation would you write? So we didn't really write an equation. What could we write? Good. He said 7 times 6 equals 42. Let's see if they did the same thing. Is that exactly what Jamal just said? Yeah, it is. All right. Notice that they use parentheses to use multiplication. That's perfectly fine. You can write it that way, okay? All right. Let's keep on moving. Let's get Miss Jemiah to help us with this next problem. All right. So we're going to go to page 9. All right, Jemiah, will you read this for us, please?
Can you solve this puzzle to find other possibilities? Positive
Possible dimensions?
dimensional posters. The new posters should be proportional
Proportional?
proportional to the original, so the image is not distorted.
Distorted? Good. What does distorted mean?
Corrupted.
Yeah, corrupted or kind of just not looking right, right? So it could either be kind of muddy or blurry looking, because it's stretched too wide or it's stretched too skinny. Either one of those would make it look distorted, okay? Um, so let's look at what we got. It says we want to create some proportional posters using the information from the puzzle. All right, so what I want us to do is I want us to suggest a possible number and tell me where to drag it to on the puzzle to see if we have the right answer, okay?
Drag 21 under 7.
All right, so he's thinking 21 under 7. What made you think that, Jamal?
Because I multiplied by 3 because 5 times 3 equals 15, so I did the other thing.
Perfect.
I did the same thing on the same time.
Good deal. All right, so he knew 5 times 3 was 15, so 7 times 3 is 21. All right, so how could we find B, someone other than Jamal? Good job. 7 times 4 is 28. So what do I need to do to find B? Najela just told us. She said we're going to multiply by 4. So Christopher Boulaz, what is 5 times 4?
20.
Great job. So we're going to pull 20 to B. All right. Layla, tell me what I could do to find how 7 inches becomes 10.5 inches.
What was that?
How would I find what the scale factor is that takes 7 inches to 10.5 inches?
Multiply by uh, 6.
All right, 7 times 6 would be 42, so that's a little too big right there, right? So think back to what we did in the beginning of our lesson.
Division.
We had to divide. So right now, what we need to do is we need to divide what by what?
7 by 10.
Okay, so we're trying to see how many times 7 will go into 10.5. So I want everybody to put in their calculator 10.5 divided by 7.
I got 1.5.
You got 1.5? All right. And so what do we need to do with that 1.5? That's right. We're going to multiply 1.5 times what to get C? Good. Izamian, tell me what that answer is going to be. Everybody should have their calculators out so we can roll quickly. Or you can click your calculator on your computer, either way, or your cell phone, or a tablet. What'd you get, Izamian?
I sound confused about this.
All right, so let me show you what we've used. So far, we've used 21 inches. We've used 20 inches. So looking at our answers right here, all we have left are these. What should we pull in to C?
Okay, so it depends. Are we timing 10 times 10.5 with something?
Okay, what we just did was 7 times 1.5 to get 10.5. So if we do that to one side of the ratio, what do we have to do to the other side?
Multiple.
That's correct. So we're doing 5 inches times 1.5. So out of these answers, which one's the best possible answer?
Two at 52.5.
I think you clicked some button wrong. Yes, let's go with Jamal. How can you help him?
I got 7.5.
All right. So I'm trying to think how you got 52.5. All right. So what we're doing is we're doing 5 times 1.5 equals.
Oh, 1.5.
All right. So you just missed the 0.5. See if you get it right now. 5 times 1.5.
First, I thought we had to add the 0.
I got you.
7.5.
Good deal. Does everybody see how to do that? Give me a thumbs up if you're getting it so far. All right. Good deal. I got a lot of people that I'm waiting on. I only got one thumbs up. Use your tools on the left side of your screen and give me a thumbs up.
They're not showing up for me.
They're not showing up today?
They're not showing up for me either.
All right.
I think when you show your screen, it doesn't show up.
I got you. Good job, Christopher. All right. So tell me this. If you're not understanding, speak up now. Don't be scared. Talk to me. Everybody understanding pretty well? All right, so we've used 20, 21, and 7.5. So that means we only have 2 answers left. So, Laney, tell me what we should do to find this answer right here.
You would.
All right, we are going to multiply something by 7. But just like the problems we worked earlier, we had to take the new measurement and divide it by the original. So what do we need to do with 18 3/4 and 5? Can somebody help her out?
Divide.
All right. So how can I divide since 3/4 is in a fraction? What do I need to change 3/4 to? Think about it. If you have 3/4, how many cents do you have? How much change do you have? Yeah. So I need to take this and divide it by 5. So let's see what we would get. And we're doing this to find out the scale factor that goes right here. I'm waiting on y'all. I know the answer. I want y'all to tell me the answer.
3.75.
All right. So what do I need to do with this 3.75?
Multiply by 7.
Great job. So we're going to do 7 times 3.75. Let's see somebody I haven't heard from. Deonti, tell me what that's going to be. Seven times 3.75, Deonti.
24.5.
You said 24.5? All right, Najela, what'd you get?
26.25.
Okay. So I'm trying to think what went wrong with Deonti's. All right, so if you have 7 times 3, that's 21, right? And so whenever we do 7 times 0.75, what would we get? Should be 5.25. It'd be like $5.25 plus 21. See if you put it in the calculator again if you get it right, Deonti. 7 times 3.75. Anybody have a question? All right, Najela.
So like when you multiply, are you supposed to like from the left side, like when you're reducing to the right side, do you multiply?
All right, restate that one more time.
So you know like how you multiply when you're on the left side but divide on the right.
Okay,
Or is
yeah.
that just-
All right, so what we're doing is we're finding the scale factor for this side. And so when we find that scale factor, we can use it on the other side. So basically, we're just using the scale factor to fill out the whole table. And so some of them, you can just do mentally and multiply, like we were talking about earlier. But some of them, we're going to have to go through and use division so we can figure out what the scale factor is. Is that making sense, or did I not answer your question good enough?
It makes sense now.
Okay. All right, well, let's keep moving. Let's go to page 10. All right, so we've seen this guy before, right? All right, so it says you have determined scale factors to find missing dimensions of enlargements. You can do the same for reductions. So we're going to see if we can figure this out by looking and seeing if we can find this missing number here. So what do we need to do? Yeah, I see it. I'm fixing to get it off of there. All right, so you'll notice that he found what the scale factor was by doing what? How's he going to find the scale factor? What's he going to have to do?
I think he divided.
That's right. That's what he's going to have to do. So if we divide, what are we going to get?
Divide, come on, 1.5.
Yep, we got to do 4 divided by 1.5. So what's that going to be? What do we think it would be? Is it going to be bigger than 6 or less than 6? Emma, what did you say? Is it going to be bigger or less than 6? All right. So somebody give me an estimate for the new height. What would it be about? How many inches? It's just an estimate. It's just got to be close.
3?
Yeah, all right. So let's see if 3 is almost there. Oh my goodness. All right, so let's check it. All right, it says our scale factor is 1.5. And so we found that by doing, or no, we're trying to find the scale factor. It's not 1.5. We're doing 4 divided by 1.5, and that's going to give us our scale factor. All right, so when we do that, what are we going to get? How do we say that number? 375 what?
Hundreds or thousands?
Thousands. Good job. 375 thousandths. So what do we need to do with 375 thousandths? Multiply it by what?
6.
By 6. Good deal. What are we going to get for our answer?
2.5.
All right, let's see. Look at there. Good job, guys. Y'all got it. So those were the answers that were on the, let's see, 9, 10, page 11. All right, and let's go to page 11. So we're going to try to complete this puzzle, and we'll check our understanding. Make sure we understand what the dimensions and the reductions are. So this is just like what we did earlier. So we should be able to go through this one a little bit quicker. And then we'll be able to dismiss from class today, okay? All right, so looking at it. It says, remember the logo that we enlarged to create a poster. Now Mark wants to reduce it to fit on an ID card. So we got to solve the puzzle. So we're going to be finding the other dimensions, okay? So let's see who we can get to help us. Razia, give me an answer for one of them. Reginald, I want you to give me an answer also. So what's happening here? What is happening from 7 to 3.5? What's 7 being divided by to become 3.5? Or what is 7 being multiplied by? It's being divided by 2, which is the same as being multiplied by 1 what?
1/2.
Good deal. All right, so what is half of 5, Reginald? Looking at our answers, which one would it be?
1.5.
That would be half of 3, but we're looking for half of 5.
2.5.
There you go. Good job. All right. This says that 5 is now becoming 1. So what's 5 being divided by?
1.
No. 5. Good job. 5 divided by 5 is 1. So that's the same as doing 5 times 1/5. So what is 7 divided by 5, or what is 7 times 1/5?
1.5.
All right, let's get it. All right, and we got one more left. That last one, what's 7 being divided by to get 1?
7.
All right. To Chandrik, tell me what our answer to C is going to be. What's the only possible answer? There's only 2 it could be. It can either be this one or it can be this one. So right here we did 7 divided by 7 to get 1. So what do we need to do to 5 to get C?
Divided by 7.
Good job. Let's check our answers. Ooh, it says we're partially correct. So what did we do wrong here? We're supposed to do 7 divided by 5. What's 7 divided by 5? Is that up here? Is that up here?
Say 1.4.
Let's see. Let's see if this will work. All right, good deal. We got it knocked out. All right, so we are going to have a little bit of work to do tomorrow. All we need to do is to finish question 6, A through D. Okay, so you're going to do question 6, problems A through D on your own, and then we'll check them tomorrow. Okay. Does anybody have a question about what we're supposed to do on our own tomorrow? All right, so we just have one page that we're going to do. All right. So to end this, why is the order in which you divide to find a scale factor important? Say that again. Why is the order important when we divide? Talk real loud, Jamal.
I said, can you put it in another way?
Okay, yeah. All right, so earlier we had to do 5 divided by 5 to figure out 1. Right. Come on, work, mouse. Right here. Okay. So what if I would have said 5 divided by 1 equals 1? Would that have given us the right answer? No. All right. Because that would have made us do 5 times 5 and got 25. Wouldn't that have been wrong? So why is it important to use the correct order to divide so that we find the scale factor?
Because if you don't, you'll get a different answer.
Yeah, we're going to get the wrong answer. All right, my guys and girls, I want y'all to have a great day. If you need any help, let me know. And I will see y'all tomorrow at the same time, okay? Sound good? See y'all later.